Hello, Mr. Witherow here again. Graphing lines. This time we're going to do it in standard form. Standard form looks a little different than slope-intercept form. Remember, slope-intercept form is y equals mx plus b. Standard form keeps the x and the y on the same side. So it's going to be ax plus by is equal to c. A little bit different, right? But just hang in there. Sometimes it's easier just to look at it like this, and sometimes it's easier to convert it to a y equals mx plus b. We don't know what a, b, and c are. We know that x and y are just going to be solid, all right? We're always going to have x and y in there, and away we go. All right, so two forms of thought here. We can have, watch this. So if I have ax plus by is equal to c, right? I can make up a little graph here, a little table, and I can say to myself, this is A and this is B. And when A is 0, or when B is 0, then I can find out what the other one is. So let me show you that. All right, so if I have AX plus B is equal to C, if X is, this is X, or this is A, right? If A is 0, 0 times X is 0. It gets disappeared. So what happens here is that we would have BY is equal to C, and then when B is 0, the Y goes away. That means you're going to have AX is equal to C. All right, remember this. This is where we have to do. What happens is, what we do is what we're finding is that we're finding the intercepts. All right, this would be the y-intercept, and this would be the x-intercept, where the line crosses the x-axis and where it crosses the y-axis. Sometimes this is really easy and simple, and sometimes it's not. And when I say that, it just depends on how well you know your multiplication tables. It all goes back to multiplication tables. Because if not, if we know our multiplication tables, then we can take a look at something and say that these numbers are all go into each other. Sometimes they don't. So sometimes you have to convert it. You got to take this and convert to y equals mx plus b, which means that you're solving for y. You're going to get your y by itself. You don't see this very often, but sometimes I do, just to see how well you understand the math. All right, so let's take a look at this. All right, if I have my first one, right, and I have that 6x plus 3y is equal to 6. If I know that 6 can go into 6 and 3 goes into 6, then I can use this form up here. I can just plug in 0 and I'm good to go. If I notice that they can't, then I got to do this over here. All right, let me show you this. All right, so this is when I use my thumb, right? So if I cover up 6x, right, that means that x is 0. So x is 0, that means I cover up the 6x. Now I have 3y is equal to 6. So I'm going to write that down. 3y is equal to 6, which means I divide by 3 on both sides and I get y is 2. So now I have my point 0, 2. So I know that it crosses the y-axis at 2. So I come over here and I'll put a dot. Now I'm going to say that y is 0. So that means I'm going to cover up the y. And I'm going to get 6x is equal to 6. So if I divide by 6, I'm going to get x equals 1. So now I have 1, 0, right? Remember that a point is x, y. X was 0, y is 2. X, y, x is 1, y is 0. So now I'm at 1, 0. So I'm right here. So there's my line, right? If I connect these 2 points, I'm going to have a line. Well, if I follow the pattern that has created here, it's been created, I can continue this line. So I'm down 2, forward 1, down 2, forward 1, down 2, forward 1. Or if I go back to the beginning and go up 2, back 1, up 2, back 1, now I have my line, all right? So it's a little bit where you have to know your times tables, right? Because then you have to know what if it goes into each other, right? So like this one here, 5y is equal to, or 5x minus y is equal to negative 5, all right? So if I wanted to, I can say that x is 0, right? I cover up that 5x, and what do I see? I see this negative y is equal to negative 5. Well, that doesn't give me what y is, so I got to divide by negative 1. Now I get y is equal to a positive 5. So now I have a 0, 5 as my point. Then I'm going to say that y is 0. So if y is 0, I'm going to get 5x equals negative 5, because I'm going to take I'm going to take this out, right? And now I get 5x equals negative 5. So now I divide by 5 and I divide by 5. I get x is negative 1. If I can move this piece of paper. So that means my point is negative 1, 0. So now I come back over to the graph. I've got 0, 5, so I go up 5. 1, 2, 3, 4, 5. And I have negative 1, 0, so I'm back over here. So there's my line. So it looks like it's 5, back 1. 1, 2, 3, 4, 5, back 1. And that should be good enough for me. I should see the pattern, and I'm close enough, and I just draw my line. All right, so nothing too crazy. So if you can see that if these numbers go and help each other out, then just cover them up. Use your finger and cover it up. That means when I cover it up, that means y is 0. So that means 6x equals 6. When I cover the 6x, that means x is 0. That means 3y is equal to 6. Same with this over here. All right, what about down here? Down here, when x is 0, so I'm going to cover that up. So when x is 0, I'm left with y is equal to negative 1. Well, heck, I didn't have to do anything with that one. So 0, negative 1. When y is 0, I'm going to get 2x is equal to negative 1. Because again, I'm covering this up. So now do you see that 2x is equal to negative 1? So I divide by 2 and I divide by 2, I get x is equal to negative 1/2, which is going to be kind of crazy, right? So my point is negative 1/2, 0. Well, now it's going to be a little bit trickier, right? So I've got 0, negative 1, so I'm down here. And I got negative 1/2, 0, which means I got to split this one right here. Look how small that is. That's going to be pretty hard to do there, right? So maybe, just maybe, on this one, I should have just subtracted 2x. What happens if I would have subtracted 2x? If I would have subtracted 2x, check me out here. 2x plus y is equal to negative 1. Let me zoom in, I'm writing them pretty small. If I would subtract 2x from both sides, right, I would be left with y is equal to, well, I can't combine these because these are not the same term, so I would write negative 2x minus 1. Look at that. Y equals mx plus b. So I'm crossed at negative 1, but my slope now is negative 2 over 1. So that will help me out here. So if I go over here and I go negative 2, 1, 2, plot forward 1, hey, now it's a little bit easier. If I start here and I go up 2 and I go back 1, now look at that line. Now I can see it. It's a little bit easier. So like I said, sometimes instead of doing this covering them up, sometimes it's easier just to solve for y, which we would just move that over. Let's take a look at our last one. Our last one here, 5 and 2 and 14. Well, I know if I covered up 5x, I can divide both sides by negative 2. But if I cover up the y, I can't divide 14 by 5. That'd be kind of ugly. So this one, I'm going to have to solve for y right away. So this is why I said you have to know your times tables, because then you know that then it helps you out. So it's minus 5x minus 5x. I'm left with negative 2y is equal to negative 5x plus 14. And then I'm going to divide by negative 2. When I divide by negative 2, I have to divide everybody by negative 2. Everybody gets divided by negative 2. So now this is left with y. I can't do anything with this, but I notice that they're both negative, so that actually turns into positive. So 5 over 2x. And then 14 divided by negative 2 is a negative 7. So here is my m, and here is my b. So the y-intercept is negative 7. So I come over here, 1, 2, 3, 4, 5, 6, 7. And then my slope is 5 over 2. 1, 2, 3, 4, 5 over 2. 1, 2, 3, 4, 5 over 2. And I'm going to say that's good enough. And I'm going to put a line in here, roughly. And then that's what we've got. So this one, when it's standard, you got to be careful, right? It's a little bit more work. Standard form is ax plus by is equal to c. Sometimes it's easier just to do this way. That's sort of kind of what we did down here, right? And then sometimes you have to convert it to y equals mx plus b. Keep having fun with math.